welcome to MathSpellBook. I'm your host, Peter, and basically we are going to get back into waves and a little bit of periodic motion because I realized, oh wait, the chapter before waves is about periodic motion, and the more we know about periodic motion, then the more we'll probably understand waves a little bit better. So I thought I would just go back a chapter and just go into maybe learning a little bit more about periodic motion. So let me just go back here for a second. Just gotta open up a Quizlet because I just realized I forgot to open it. But how are you guys doing? It is Tuesday. Hopefully you guys are having a great Tuesday. If you're, if you're basically having like an off day, hopefully the stream will help you feel at ease and maybe keep yourselves uplifted a bit. At least I hope so. Anyway, I did start reading this chapter a little bit this morning. I did this problem this morning, this example problem, so I won't do that again. I was reading a bit about simple harmonic motion. So we have a couple equations here. So I thought maybe we can just do a problem here. So let's just do this example problem. Then drag it over here. Okay. So let's see what this one says. Let's see, a spring is mounted horizontally with its left end fixed. A spring balance attached to the free end and pulled towards the right. Oh, we have a figure here, so maybe we should have a figure. Okay, so I'm trying to get the figure without looking at the answer, so let's do this. I think what we can do is that we can drag this over here. Okay, you guys can still see that. And then paste. And then drag this here. And then expand it like that. Okay. I think that would be good. Okay. That is the right figure, right? F14. Okay, this is the description of the, because I'm trying to make sure that I don't look at the answer, because I don't want to look at the answer. Yeah, okay, so that's included. Okay. Paste that there, just in case if there's other info that can help us in the problem. Okay, so let's see. Horizontally, a spring attached. Okay, so we have like a mass right here. Indicates that the stretching force proportional to the displacement. The force is. So I'm just gonna write Hooke's law because that's what we have, and it's kx. All right. So indicates that the stretch force is proportional to the displacement of a force of 6.0 newtons causes the displacement of 0.0330 meters. We replace the spring balance with okay, so we have a mass now, and the glider is pulled back right along a frictionless track. Okay, that helps us so we don't have to worry about friction. Releases it from rest. Find the force constant k of the spring. Find the angular velocity. Oh, okay. I mean angular frequency and the period. Okay, so from what I remember, but also this is equal to the frequency, and this is also equal to pi times. Okay, so I think this is all the equations we need. So what what we know. Let's write what's known. So, what's known is the force, 60 newtons. And then the first displacement we have, we'll just put that as displacement 1, 0.30 meters. So I'm guessing we're gonna have to use these two to get K here. And then we'll use K to basically calculate the rest of this stuff. So, so we have, let's see, we replace the screen with okay, so now we have a mass. That's gonna be in the second part of the problem. And that's pulled by, we'll call that x2, because that's gonna be a second part, so 0.020 meters along a frictionless track, which helps us. Okay, this seems like a pretty standard problem. Okay, so now we gotta figure out what K is. So I'm guessing, like with this, because if the force is positive, the displacement has to be negative, hence the negative sign here. So technically we should probably have this negative symbol here. So for A, we have to calculate the constant spring force. So that will be equal to, and we're gonna assume, because what if this is positive, then this has to be negative, and if this is negative, then this has to be positive. So at least that's what I read in the textbook, because it's supposed to be that the relationship between these two, the reason why there's a negative sign here is because it's supposed to annihilate the negative sign within this. So 6.1, divide that by, so that gives us 200, and I want to see the units. So the units, force is newtons over meters. So then we're just given newtons per meter. But then again, we have to remember what is newtons. I think it's meters. It's kilograms, meter, and that's acceleration. So meters squared. So if that's the case, then we're gonna have to do newtons times meters. So that leaves us with kilogram. Leaves us with kilograms per second squared. I mean, that's how the units look like when I organize it. Okay, so now we gotta figure out what omega is, which is the angular frequency. And we have the mass. So, now the thing of it is that I want to pull it along a frictionless track and release it from rest. Find the angular velocity. So, now is the force the same? Release them, so pull back, pulls the frictionless track. So let's see. Force exerted on the spring, the x component is plus. The force exerted by the spring is, the x component is less than. glider is attached to the same spring and oscillates. Okay. We have is kilograms per second, and that's over kilograms. So these two cross out, so we have, and I think this is supposed to be radians, 20 radians per second squared. Well, then again, we also have the square root, so it's not squared anymore. Okay, so something like I'm trying to make sure that I keep the units correct. So we got 20, and now, so we don't have a frequency, so we gotta figure out what the frequency is. But I think we can do that. So in this case, when we figure out the frequency, it should be, we should convert it to F is equal to omega over pi 2, and that leaves us with 3.18, and this frequency, so it's hertz. So just put these in squares so I know which is which. And then we gotta figure out the period. Hey Sascha, how's it going? What's the best part of your day so far, my friend? So now we got to, so it's pi over, so now we just flip this, so this will go into, we'll have this over this, which makes this omega 1 over omega, and then we'll multiply that so that t is equal to 2 pi omega, which makes t equal to not much. Oh, okay. Well, hopefully, like, things turn out better down the road. So okay. Now I'm pretty sure that's how we set it up. Now the thing of it is that the glider is attached to the spring and allows the oscillation that we have. Because I'm wondering why they give this detail here. Because I mean, I know why they give us the mass, but do they need us to do anything with this 0.020 meters? Unless I'm thinking too much into it, because the way it seems like, now the thing of it is that I don't know if we have to find the K for this particular thing, because we did find the K for this, but it says find K for the spring, and if the K constant is, if this is the same spring, then the constant, I think it should be the same. But at the same time, if I were to find a different K with this scenario, I don't know if the force would be the same. But if the force is not the same... Huh. I mean, the string constant will be the same, but let me see if the... Because maybe the force is not the same. Because this is supposed to be a distance of... So you pull that out to the right, and then so it's negative 0.0 meters, and then multiply that by 200. That would be like negative 4 newtons at that point. Be missing something, but I mean, the way it lays out, this is what it would look like. But of course, I don't know if the K is different. It might be the K is different, but we'll see. Okay. So we got 200, yeah, that's 200 kilograms per second. Yeah, that's what we got. And then 220 rads. Yep, that's what we got. 3.2 hertz. Yep, that's what we got too. And yeah, we got, okay, so that is right. Okay. So everything we did is right. Okay, here we go. Let's see what this says. The amplitude oscillation is the displacement that we pulled the glider before releasing it. The simple harmonic motion, the angular frequency and the frequency and period are all independent of the amplitude. Note that a period is usually stated in seconds rather than seconds per cycle. Okay, so we managed to get that correct, which is good. So I guess that number was just meant to just give us like just data. Sometimes like with problems you don't like I guess with physics problems sometimes they could put numbers there just to like add to the scenario, but sometimes you never know if it's actually part of the problem. But then again, it could be a way to actually confuse you and make you question the data. Alright, so what's next? Displacement, velocity, acceleration, it's a simple harmonic motion. Okay, so we got a typical trig function here. So thanks for the clap emotes, Sascha. So now, oh, okay, so I'm guessing we're gonna have to do derivatives with this because it's gonna show. So this is the position as a cosine, then okay, so omega times t, okay, that would equal pi, 2 pi, interesting. Phase angle, okay, what is this one? The constant phi in equation 14.13 is called the phase angle. It tells us at what point in the cycle the motion was at t equals 0. I kind of like those emotes. Yeah, they're cute, very cute emotes. So someone just randomly gifted me a sub to a random channel which I wasn't even a follower. Oh, okay. It's kind of weird how that works. Unless like the gift system just randomly gives people gifts. I guess. Hey, Mean Machine Rex. Bonjour or salut. Wait, salut. Yeah, actually, Sascha, I've been starting to watch Code Lyoko in French. Like, I think the only French word I got from that was like "qu'est-ce qui se passe?" What happened? I don't even know if I pronounced it correctly. Why are you asking the question who? Or is it like did I say something else? What does mon ami mean again? Does that mean my friend? Okay. Because I thought like for some reason I remember like when I was watching Code Lyoko I was starting to look up words, and I think ami, I think like I looked up and it said friend and I was like, oh, interesting. That just came out in the back of my mind. Sometimes when I study language, well, like when I actually learn a little bit of languages, sometimes it's back in my mind and then it suddenly gets triggered whenever I see it again. But sometimes I don't know exactly what it means, but I have a feeling I know what it means. I mean, that's how I managed to learn Japanese like a while, because like I remember I would hear a word and then suddenly the word would pop in my head, and I don't remember exactly the translation, but then I would remember the feeling of what the word kind of gave me, and then I would try to guess like the word, like the translation of it, and it would be kind of very close. I watched the entire series of Nicolas de Loche. What is that? What type of show is that? Feroce. What is that? You said entire series, so I'm guessing it's a show. And what's the show about? Maybe I'll check it out. I'm actually currently watching a show called The 11th Hour. It's like an old show, but I'm kind of enjoying it. It's like a police procedural. Okay, so we have this lineup, so I think we should write this equation. So they would use x. Oh yeah, so it's supposed to be the position. So I'm guessing this is position of simple harmonic motion. So it's x equals a cosine omega t phi, right? Oh, it's plus. Yeah, I had a similar experience learning in English in elementary school. For some reason, I had a fixation on the word basically. Oh, okay, I see. Yeah. Yeah, it's kind of weird because like when I was trying to cause whenever I was watching Code Lyoko, whenever they would ask like each other what happened, like the English translation, what happened, I would hear like I think the phrase "qu'est-ce qui se passe." I think that's what I would hear. But then when I would type it in Google, like what happened, it gave me like I think like a longer phrase. I think they added something in there. I don't remember what it was, but it didn't sound exactly the same. Unless the way they were saying it in Code Lyoko is more like the informal way of saying it. Or maybe I'm mispronouncing it. Yeah, it's more informal. Oh, okay, I see. Like, that's like what you would say to your friends, right? Like, que passe? And if I'm pronouncing it completely wrong, please tell me, Sascha. I don't even know what that is. Oh, anyway, let's get back to what we were doing. So we probably should write this too, because that's actually a really interesting relationship. So we have t equals k over m, which is equal to t, and that itself is equal to 2 pi, right? Yeah. And then we can have t equals 2 pi times that. Oh, it's reversed. Oh, cool. That's the way I want to erase. So it's like that. Okay. I wouldn't say it like that. I would say Queses pastel? Is that how you pronounce that? Trispin. Does that mean that's good? Mean machine Rex? I don't even know if I pronounced that right either. Because when I see B-I-E-N, I think of bien, which is I think Spanish for good. I think, or unless I'm mixing up my Italian and my Spanish. Oh no. No, I think in Italian it's bueno, isn't it? Oh, I don't know. Yeah, it's good. Oh, okay. I don't know what means, but Google gave me the handheld vacuum cleaner as the first result. Yeah, I was like, what is that? Like, what does that mean? Oh, anyway, let's get back to this. Okay, vibrations of simple harmonic motion. In case that's shown. So, okay, the constant phi or phi is called the phase angle. It tells us what the point in the cycle the motion was at time 0. Okay. Well, yeah, that makes sense, because if you have time 0, then you're just left with this. Vavavoom is an informal term often used to describe something that is exciting, rigorous, and okay. It can also be referred to as the quality of being interesting and appealing. Okay. It's typically used to describe a person or thing that has strong, vibrant, and captivating presence. Oh, okay. Interesting. That's some compliment, yeah. Actually, Mean Machine Rex, how's your day so far? What's the best part of your day? Okay, so I'm guessing now we're gonna have to do the derivative of velocity. Oh, okay. So makes sense. Okay. Okay, so this one's not in yellow. That's fairly interesting. But then again, if you do the derivative, it's probably like easy to do that, so. So we take the derivative of xt. Then we're gonna be left with plus sine, well cosine, then plus, well, technically there wouldn't be, well, no, actually they might be. If you do the u, and then that, and then take the derivative of that, yeah, it would still be there. And then you take the second derivative of that, then it would be squared, and then back to cosine, and then omega. Ooh, that doesn't look right. Then omega t plus phi. There we go. Looks okay. Does it speak French like doi? Oh, I'm guessing that's you looking up the definition, right, Sascha? The link you posted. Okay, so alright, so acceleration. Oh, okay, so this might be a good formula to remember too. Because we're given the acceleration of the x here as, I like when equations just pop out because it looks really cool to me. It's like we have so much details. And then minus km is x. Okay, so oh, so you can find the amplitude this way. Interesting. So yeah, we have a lot of like expressions to deal with. Guessing this is at time 0 because so I'm just gonna write down t is equal to 0, and then we have cosine, oops, not theta, phi, like so. Then that would lead us to omega tan phi. Or phi. Then, so the arctangent is, that is pretty cool actually. I'm not gonna lie, that's actually a pretty cool like relationship to see. It's like you basically are just given you're just basically given like two random things and you can just find other things. I think that's the thing I like about physics, is that every part of the physical system has like a mathematical relationship with each other to another thing, even though they may seem they're you don't see them like in the actual equations themselves. So now we have to, if we get the amplitude, so it would be a equals the distance naught plus v naught x, I think. Yeah, v naught x over omega squared. has both the initial displacement and a non-zero initial velocity, the amplitude A is not equal to the initial displacement. That's reasonable if you start the body at a positive x naught, but give it a positive velocity v naught x. It will go further than x naught before it turns and comes back. How do you call this in English? Let me see. Actually, like, I forgot what they call this thing. Like, I mean, we've seen it so many times that I actually forgot what they actually call that. I don't think it's called a parking stop. Now I gotta want to Google that because I'm like, what did we actually call those things? Oh, it is called a parking block. Okay. Or they call it a wheel stop. Oh, hello, Saifus. From YouTube. Welcome into the MathSpellBook live stream. So basically today we're gonna be doing some periodic motion. We're doing periodic motion and a little bit of waves. Oh, interesting. In French we call it doudain, which translates into goat's back. Interesting. Because I know you guys don't pronounce the S. So what is it? It's like doudain? Is that how you pronounce it? Alright, so let's see. Simple harmonic motion describing motion. Relevant concepts. Distinguish between two kinds of quantities. The properties of systems including mass and the force constant K, and the quantities derived from these independent properties of motion, which describe how the system behaves when it's set into motion in a particular way. We include the amplitude, the maximum velocity, and the phase angle, and the values of x and v's. If necessary, define the x-axis. Okay, evaluate your answer. Make sure that your results are consistent. For example, you use x naught and v naught x to find the general expression x and v and vx at time t if you substitute. Okay. Oh, we got another problem. So let's take a picture of that and see if we can solve it ourselves. Let's drag this over here. Example 14.2. I think that was the previous problem we did, right? Yeah, 14.2. Okay. We give the glider in 14.2 an initial x to the initial velocity. Find the period, amplitude, the phase angle, of the resulting motion. Write equations for displacement, velocity, and acceleration as a function of time. Okay. Okay, so we're given, the knowns we're given are x naught is positive, and the v naught x is 14 point, oh no, what am I saying 14? It's 0.40. Okay, so I think that should be enough because in the equations we have here, it's like, yeah, we have tangent. Actually, I have to read about the negative sign. I forgot to read about the negative sign in there. Where is it? There it is. Does it say anything about the negative sign in here? I just want to be cautious. I don't want to mess anything up. Okay. Because sometimes they tell you that, like, oh, this is supposed to be negative and all that stuff, like, you know, because it's the relationship. The A is pronounced like, oh, okay, so it's like the Japanese ah. So da ain. Dane. So do dane. Imagine you're rolling a. Interesting. So I guess we can just plug this in. So find the period of the amplitude. So I think we're gonna have to find the phase angle. I think the phase angle we can find. So that would be arc, tangent, negative v for x naught, right? Oh yeah, we need a. Oh wait, we don't have omega. We probably should look for omega. So what we know about omega is equal to I think k over m. We don't have any of those, but it's also related to this relationship and this relationship. Dudan. Interesting. And the E is mu. Oh, okay. Oh yeah, because you guys don't pronounce the last E sometimes, right? Depending upon the word. That's pretty decent. I try. Like, the thing of it is that, like, I don't know if if my French would sound good. Wait, I just remembered, like, random French. Like, je m'appelle means, like, my name, right? Yeah, it's a bit convoluted to figure out when we pronounce letters. Yeah, because, like, I think it's because, like, I think in the West, we're so used to French accents sounding so very thick. My name is okay. Because I know je, I think je is, like, I in French. Like, I think, like, little bits of French are just popping in my head. I think it's because of the weekend I spent watching Code Lyoko in French. I do love the theme song from Code Lyoko, like in its original French. The I is J. Okay, gotcha. Anyway, let's get back to this. Okay, so the amplitude. So maybe we can, let's see, the amplitude is, but we still don't know what omega is. So, so the thing that's holding us back is just finding out what omega is. So, oh, we can probably work with this relationship. Because... But... we still don't know what the phase shift is. But I feel like it might help somewhere. Omega. So let's see, we're given a glider. Oh, maybe we have to look at the original problem. Maybe we can get clues from there. So it's taking this, so we have to remember that we're also given a mass. We're given a mass of 50 kilograms. And I think I feel like we should write this down, the distance, but that might not help us, but we'll write it down anyway. I don't know what value I can give it though. No, I think we already have this, so we have the mass. Now we just have to sort it out. I think we figured it out last time, right? Yeah, so K was, I think we already have K already, which is 200, I think, kilograms per second squared. Alright, so I think we have omega already, which is... So now for omega, we can calculate that. So omega in this case is square root of which is equal to 20 radians per second. And now, since we have omega, we can solve the other things. That leaves us with negative 50. Oh, maybe we have to keep it in radians, because that's degrees. I just realized I have it in degree mode, so maybe we have to change it to radian mode. Unless it doesn't matter, so because before we had it at, so we'll just leave it in that in degrees, and then we'll also have the radian mode. So negative 0.40 over 2 times, oh no, 20 times 0.015. So that would be negative 0.90 radians. Pronouns are a bit different in English. You is either tu or vu. Tu is singular and vu is plural. Yeah, I think that's the same with Spanish in Spain. They have like a similar, like, I guess, kind of word structure, like pronoun structure like that. However, vous can still be used to address a single person in formal context. Right, yeah. I think I looked that up when I was like looking up stuff about French in YouTube. And I think, what's the one for we? Is it, I think it's no or non? I don't remember. I know it started with an N. No or on. Oh, okay, yeah. Because I remember hearing that in Code Lyoko sometimes too. On is conjugated as third person. Oh, okay. Gotcha. Okay, so where was I? Oh, yeah. So we'll have these two forms. More likely, I'm probably going to use the degree mode because, I mean, the degree one because I'm so used to it. But then again, if they require us to have it in radian mode, then we'll have it here. So now we have phi. Now we need so we have the phase angle. Now we need the amplitude, and the amplitude I think we can get. So that is so for a it will be the square root of x naught, I think squared, and then v naught x over omega squared. Is that it? Oops. Okay. Okay. So now, type this in my calculator. So we have 0.05 plus 0.4, right? Yeah, 0.4 squared over 20 squared gives us an amplitude of 0.05 0.025. Okay. He and she are il and elle. But we don't have anything like it. Yeah, because I think like because your nouns either are feminine or masculine, and I'm guessing you probably use like one of those two to define which type of noun it is, based on like whether it's feminine or masculine, right? Since you don't have a particular word for the word it, that's what I'm guessing. Okay, so we have this, we have this, and now we have to write the actual equations down. So we're given, oops, so x is equal to cosine, and omega is 20t plus let's go with the degree mode. I mean the degree form. Because usually when I work with physics, I always see the degree form mainly. So I think we're gonna have to multiply our amplitude. So it's a half sine. It's supposed to be sine. So minus sine 20. And then acceleration, that's going to be it's going to be 20 to the square, then times this by 20. That give us 10. So negative 10 cosine. They probably use the radian form, but I just chose to use the degree form because I'm so used to working with degrees. Yeah, exactly. If the context is ambiguous, we default to ill. Oh, okay. They become ill and ill or illes. Oh, okay. So is this the form that you pronounce the S or you don't pronounce the S? Based on genders, however, if like, do you only see the S when it's like written form? But like, do you pronounce it without the S? However, if you have a group of people, like one man, yeah, I remember hearing about that. We don't pronounce the S. Okay, so basically, it's just written like that. So it's mainly like just written that you see it. Okay, so it's like ill, but it could be it, he, and for LA, it's basically it could be like she or it, right? So I think that is our stuff. Let's see the example. Oh, so they did use the radian form. Okay, maybe the radian form is probably better to use. Because I had a feeling they were going to probably use the radian form. Because I think it's because it doesn't have units. That's why it's probably easier to use. Okay, yeah, they did it the way I expected. Okay, so we got this one right. Cool. My thought process was correct there. Cool. Yeah, exactly. Okay. I mean, I don't know, like, when I would probably be able to, like, speak French. Like, maybe it'll probably be when I'm, like 40 or, like, 45, depending upon how much I want to learn it. Because I think I just look at it as something that I would do passing. Because I like the way you guys say different in French. Différent. It sounds so eloquent. Because I always remember the first lyric of I'm trying to say it in French because I know in English the theme for Code Lyoko is called A World Without Danger. I think in French, like, I'm trying to remember the pronunciation of it. Because I can only remember it when I think of the song, when I actually think of the verse. Au monde des en danger. I think that's how you. I think that's the way it's pronounced. I think. I don't know. Okay, so let's see. Oh, energy. Ooh, energy in simple harmonic motion. This is something interesting. Let's see what we got. Oh, there's kinetic energy plus half of K. Interesting. So this is the total mechanical energy. Oh, it's a constant. Okay. Well, then again, energy is supposed to be conserved, so does that mean that half times K x squared? I wonder if that's the potential for a spring. When I was learning English, I was a bit confused regarding it for animals because some English speakers use it for wild animals and say she or he or she for their pets. Yeah, which is confusing. Yeah, I get that. Yeah. I think it's because, like, for pets, they consider it part of the family. That's why they use, like, you know, he, masculine and feminine pronouns for their pets. guess we'll just write this formula here. Yeah, I think doing the example problems actually helps like make my mind kind of absorb the material a little bit better. Energy in simple harmonic motion. Because we are learning a little bit about waves and periodic motion. So it is the energy is the kinetic energy times, what is it, V naught x? Oh, it's just x, okay. Where's that? X plus half. Oh no, it's k. It's supposed to be k. K to the x squared. What else? That is all equal to a, and that's all equal to a constant. Oh, okay. It is the potential. Yeah, that's what I was thinking, because I'm thinking it's supposed to, because it says it's the total energy. Yeah, it's the total energy of the simple harmonic motion. I was gonna say oscillator. I'm like, this is not an oscillator. An oscillator is what's going through simple harmonic motion. Oh. Let's see. Oh, interesting. So basically they just break it down. Oh, that's cool. Actually, I like the way they formatted that. It looks like, for some reason when I see like equations like derive in a little bit more of a complicated mess sometimes, I find it very interesting. So omega a sine omega time plus omega, and that's squared. Yeah, we'll just leave it like that. Make it, that's as nice as I can make it. Okay, then k, and then we have a cosine omega t plus theta, or phi, I should say, phi squared. That actually looks cool. Yeah, and then these will turn into 1. So then we're left with k. Oh, okay, that's really cool. E in this context is pretty much the Hamiltonian of the system. Okay, so that's good to know. So for Sascha's reference, Hamiltonian. That's something to keep in mind. Okay, so let's see a graph. Okay, yeah, it does tell you here. It's like the potential, the kinetic plus the potential. So they use U for the potential. Okay. Ooh. So they tell us what V is. Okay, that's something to keep in mind. So in this case, Vx is equal to plus or minus m. Then we have the amplitude minus squared minus the position, which we can break down even further. Let's see. It means that the given value of x, the body, can move in either direction. For example, when x is, okay, so this is an example they use. Okay, I thought it was another formula. Okay. Okay, oh, here's the max speed. Okay, so max, that is km over m times a, which is omega a This agrees with 4.15. Which equation is that again? Oh, okay, this one. Okay, so it's the velocity. Ooh, went down too far, I think. Yeah, here we go. Hamiltonian mechanics is such a cool formulation of classical mechanics. Yeah, I can't wait until I can get to that level, but I'm still lacking in knowledge when it comes to that. But you know, we're building step by step, so hopefully we'll be able to get to there. I mean, I know the Lagrangian is basically the total, no, not the total, but the kinetic energy minus the potential energy. Although, do I know how to derive the function of the potential energy? Probably not, because I haven't fully understood partial differential equations yet. And I think once I'm able to understand the basics of partial differential equations, I would probably have to learn the calculus of variations. Interpreting E, K, and U. Shows that E, K, and U, X is half. It is a graphical display of energy represented. Okay, so let's see. The total energy of E, which we have, is a graph here. So U is the potential here. Alright, let's see what we have here. For computing potential, you just need to how a line integral works. Oh, need to know how a line integral works. Okay. I think we were solving for arc length last time, like a couple of streams ago, and then that was supposed to help us to learn line integrals. Okay, so we're given another problem, so let's have a little fun. Paste, and oops, drag this, and then we'll bring this up here. Okay, so we're still given that same problem, so we're gonna have to rewrite everything. So we have to remember the mass. Mass is 0. About a half a kilogram. And I think we had the omega here too. Oh, we had the K, yeah. So the K is 200 kilograms per second squared. And find the maximum and minimum velocity obtained by the oscillating glider. Find the maximum and the maximum acceleration. Find the velocity x and the acceleration a when the glider is halfway from the initial position to equilibrium position of x equals 0. Find the total energy and the potential energy of the kinetic at this position. Okay, so I think we actually need the distance now. So I think we might need to use these equations here. So erase this part here. Find the maximum and minimum of the acceleration. So we have to find the maximum and the minimum velocity. So in this case, so we already have omega, so we can find the max velocity. So we have to write omega is 20 radians per second, and the amplitude is 0.25. So if we do the max, so then square root of then 0.5 kilograms, and then times that by 1.0025. So that leaves us with 0. meter per second. So that's the fastest it goes. Now I have to figure out what the minimum is. So this is the max. So now we have to figure out what the minimum is. So I guess we're gonna have to solve this equation for when it's 0. Because I'm basically doing like the anti-side and the anti-side on both sides. tell us how to get the max. I'm wondering which one is the minimum. Like, how do we actually calculate the minimum here? The graph will show us. Let's see. The same graph shows the kinetic energy as well. So this is kinetic and this is potential. So the energy is E plus 1. Kind of reminds me of like when you had to figure out the area underneath this, under the two curves. Figure out like what shape it is. Like, you know, the was it the washer method and the was it the cone method? No. The disc method and the washer method. Yeah, I think that's the thing that you learn in Calc 2. I think like I started that like in the beginning of Calc 2, and I was like, what the heck is this? And it took me like, I think like maybe like a while to actually get used to it, because I was like, wait, what are we supposed to do? Because I couldn't figure out the axis, like which axis to take the integration from sometimes. Energy, potential energy. Each value of x is sum of the value of k and u equals the constant value of e. Can you show that the energy is half the kinetic and half the potential of x? acceleration. Find the velocity x and the acceleration ax when the glider is halfway from its initial position and equilibrium position until it was. So we got the maximum. We were off by like 0.1. It's maximum and minimum, most negative velocities. Oh, okay, so it's like, I had a feeling it was going to be like, they're two halves of like, almost the same coin. It's just that one is negative and one is positive. Acceleration. Like, I'm just like looking over like the results here. It's like we get the max acceleration and the minimum acceleration. So I'm guessing because it is, I mean, because it's a simple harmonic system, I'm like, I guess it's because it's like very symmetric. So that's why like the max acceleration is the positive version and the minimum acceleration is the negative version of the value. Oh, so they did use the distance that it traveled in the, I think the first two examples ago. Well, I think this is gonna be my stopping point for today, guys. I know it's a bit early, but I feel like my energy is like slowly kind of being like, I guess like kind of like fading from I guess like the first three problems that we did. Now, of course, like, you know, I would try to push on, but I don't want to like feel like I'm just dragging my enjoyment of the material. It's like, for me, like whenever I study, I try to like study into the point where it's like I'm I'm like at the proper rate. But at the same time, we went through like at least an hour and a half of study time, so I think that's still an achievement. So I think like whenever my brain gets like this, I would say, okay, we did like an hour and a half of studying. I think that is good enough for today. But thanks for joining me today, guys. If you like math and physics and you want to tune into the next math and physics streams, or you just need a study stream to keep you occupied, if you're watching this on YouTube, hit the sub button and hit the like button, as well as if you're watching this after the live stream, put a comment down below and tell me like what other topics you want me to cover within physics or mathematics that you would like me to like take a look at, and probably try to master on my own as well. If you're watching this on Twitch, drop me a follow. It always helps me out and motivates me to continue making these math streams for you guys, or math/physics streams for you guys. I'm starting to get into chemistry, so I'm trying to learn the basics of chemistry, and I really want to get into this book called Quantum Chemistry. Like, it's a really good book because the way it's read, it doesn't assume that you have physics knowledge, but it does assume that you have chemistry knowledge. But I find it pretty intriguing, especially since it's dealing with atoms and chemistry, so it's kind of like uniting like two sciences together. It probably might help me get into chemistry a little bit more. So that's kind of what's my motivator a bit. But yeah, so if you guys want to join our Discord, as well as my video game channel, if you're watching this on YouTube, all the links will be in the description down below. But on Twitch, I will type that in for you guys. So we got the Discord and my Uncle Talks channel. And if you're watching this on YouTube, my MathSpellBook channel, Twitch channel is like down below as well in the description. Okay guys, I think that will be all for today, and always remember, everyone is precious. You guys are just as precious as everyone else, and we will see you guys in the next stream. So take care guys. Bye-bye.